So now starts today's class. Have you got all of you got the assignment?
Yes, ma'am.
Yes, ma'am.
So now we have already solved.
Ma'am,
Huh?
ma'am, one query is there.
Ask me.
Ma'am, regarding that assignment, ma'am, you have given one question. AB
Hmm.
whole complement is equals to A complement plus B complement. You have told what does this mean? Explain in one word. Ma'am, we have to write the law that is telling in that
One word
complement.
or own word?
My own words, yes, ma'am. Own words, yes, ma'am.
Yes. Identify the relation, and if it is a law, then give the statement of that law.
Acha, acha, okay, okay, got it.
Okay. Or any question? Any other question? Shreya or Kushmit, Vinayok,
No, ma'am. I also
Sudarna?
had the same question.
Okay. And from Shreya, do you have any question? Shreya? Shreya, are you there?
Ma'am, she is not here. She was. I think she got disconnected.
So, Kushmit, when I am starting the class, only 4 or 5 students are there.
Ma'am, actually, the
Why?
last class just ended. I think they are joining.
Okay. So, if they have any query regarding assignment, they can ask also. Okay. So, now start to continue with this topic, that is how we can represent the expression which is given in the product of sum form on Carnot map. Here the expression is given. In which form it is given?
Ma'am, ma'am,
Yes.
ma'am, myself, Udvardhan Mundul. Yesterday's lab class I have missed because I have some football trial in college.
Yes, Arkoshmit informed me.
Yes, ma'am. But
Hmm.
what actually I told you that tell you
Hmm.
that can I get the recording of that class of that lab class by
Uh,
anyhow?
I can provide you the recording, but first thing is go for the assignment one. Okay.
Okay,
Acha.
assignment,
And
that lab assignment.
regarding the yesterday class, I also continue it with the same thing in the next lab class. Okay, that is in the coming one day.
Okay,
If
ma'am.
you have any query, then you can ask me. Okay.
Okay, ma'am. Okay, ma'am.
Okay. And also, if you have any query or any questions, you can ask Binayok or Shubhadeep or Kushmit. Huh?
Yes, ma'am. Yes, ma'am.
Okay, ma'am.
Now, it is given in the product of sum form. All of you can identify this representation. It is given in the product of sum form. Is it clear?
Yes, ma'am.
Okay. So now from this, how we can write the max term for this term a plus b plus c. I have already discussed about this. That is, in max term, when it is given a plus b plus c, we will take the input for a is 0, b is 0, c is 0. Is it?
Yes, ma'am.
Yes, ma'am.
Then this is corresponding max term 0, this will be max term 1, this will be max term 2, and here it is 6. So in Carnot map, draw a 3 variable Carnot map and put 0 in the corresponding max term position. That is 0 here, 1, 0 here in the max term 1 position, here and here. Because 0, 1, 2, 6, these 4 will contain 0. And what will be the others value? Others value will be 1 in case of product of sum form. Then when we, how we can solve this? By taking this 0 for our considerations. Taking this 2, we can make a pair. Taking this 2, we can make a pair. We will get the result. Okay. So now I am going to solve some problems based on this form, that is product of sum form. First, try to do this problem. Simplification of expression which is given here in this form. Y is a function of ABC, which is equal to product of max term 0, 2, 4, 5. This is given here 0, 2, 4, 5. So for these cells, we will take 0, and for other cell it will be 1. Then what will be the result? Can you understand this?
Yes, ma'am.
How? How we can calculate it?
Ma'am, a complement plus a is equals to 1, and
Yes.
by complementary law, and that
Yes.
has been
So
done
here,
here.
just follow this method, taking these two, make a pair, okay? So if we solve this in the min term form, then what will be the term in the product term for these two adjacent zeros? A bar, B, or A bar, C bar in min term for these two adjacent zeros. What will be the representation in the min term? A bar, C bar.
Yes, ma'am.
So in min term, if it is A bar, C bar, then you can write it easily in the max term by complementing that. So in max term, it will be A plus C. Is it clear?
ম্যাম মানে মিন টার্মে যেটা ম্যাম এবার
Min
সিবার
term এটা কি হতো যদি
এবার
suppose min term if these two adjacent cells contain 1, suppose, then what will be the result here? A bar,
সিবার
C bar.
হ্যাঁ
Then in case of max term, it will be A plus C.
ম্যাম ওটা মিন টার্মের অপোজিট হয়ে গেছে
Opposite, just reverse.
ওকে ম্যাম
If suppose the min term position M0, what is the combination? A bar, B bar, C bar. But in max term, M0, capital M0, it represents A plus B plus C.
ইয়েস ম্যাম ইয়েস ম্যাম
So if it is in complement form, take it as normal form. And in product term, there is a dot in between the literals, right? Because that is a product term. But here it will be odd term. So take A plus C. So how we can solve this pair? What will be the min term for that? A. কি হবে? A for these two.
ম্যাম এটা হবে হচ্ছে
B bar
এ বি
plus
In min term আগে বলো. Just
হ্যাঁ ম্যাম মিন এ বি
A
বার
plus B.
A B bar.
Hmm.
A B bar. So what will be the max term?
এ বার প্লাস বি
A bar plus B.
If it is consider 1 here and 1 here, then these two adjacent cells make a pair. Then what will be the result in min term? Then it will be A B bar, right?
ইয়েস ম্যাম
So
Yes,
how
ma'am.
we can change that in the form of max term? A B bar is given. So take the complement of A, that is A bar. and it was B bar. So here it will be B, and there will be a or symbol or plus symbol in between them. Is it clear?
Yes, ma'am.
Yes,
So
ma'am.
in this way, if you can understand how we can solve the expression with the help of product of sum form, a sum of product form, then you can also get the result. You can also write the result in the product of sum form also easily. Just consider 1 instead of this 0. What will be the result in the min term? Then change it into the max term.
হ্যাঁ ম্যাম,
Then
বলছিলাম ওখানে ম্যাম a প্লাস বি প্লাস সি ইন্টু a প্লাস বি বার প্লাস সি, ম্যাম এক্সপ্লেনেশন ওখানে ম্যাম কি করে আসছে একটু বলবেন? ওই যে
এই পার্টটায়
হ্যাঁ হ্যাঁ, পাশের ব্যাপারটা।
explanations for pair 1.
হ্যাঁ, পেয়ার ওয়ান।
Pair 1,
হ্যাঁ ম্যাম।
here the term is first a bar, b bar, c bar. So what is the max term?
ও আচ্ছা ম্যাম, বুঝতে পেরেছি।
This is the min term value, a bar, b bar, c bar. Okay.
হ্যাঁ ম্যাম।
So what will be the max term? Max term will be a plus b plus c. And for this term, min term is a bar, b, c bar.
হ্যাঁ, ওটা হবে a প্লাস বি বার প্লাস সি।
Yes. In this way, you can write in the max term position.
ওকে ম্যাম।
Max term value. Okay. So now go for the another problems which is given here. Problem 2. Do it by yourself and your answer you can verify it with this. Just do it in your copy. Problem 2. First thing is here the maximum value which is given here, that is 15. So it will be 4 variable functions. Y will be a function of 4 input variable A, B, C, D. So it will be a 4 variable K-map. So please do it in your copy and check whether you are getting this answer or not. Just do it. Are you doing this?
Yes, ma'am.
Yes, ma'am.
Okay, do it. If it is over, please respond.
হ্যাঁ ম্যাম হয়ে গিয়েছে।
হচ্ছে?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
So there are 4 adjacent cells. It make a quad, and from here, which
ম্যাম
little we can draw? Yes. Who is speaking, please? From this quad, what will be the output? B literal will be dropped here. So it will be A, and here it will be C bar. A C bar. But A C bar is in min term representation. So in the max term, it will be A bar plus C. Is it clear?
Yes, ma'am.
Okay. Then another pair is here, and
ম্যাম
these two adjacent cells also make a pair. So
ম্যাম
you
এই
will
কার
get
এই ম্যাম এই কার্নো ম্যাপটা তো আমরা মানে পিওএস এর জন্য যেরকম ভাবে রিপ্রেজেন্ট করে ওরকম ভাবেও তো করতে পারি, মানে প্লাস
হ্যাঁ
লিখে
করতে পারো,
না,
করতে পারো, একদম তাই। So you can
তাহলে আর এই রিভার্সটা করতে হবে না পরে।
না, you can do it in this way, or the another way is there by following the solution in POS form. Okay,
মানে ওই নোটেশনটা লেখার সময় খালি ওটা রিভার্স করে
নোটেশনটা
দিতে হবে।
লেখার সময় চেঞ্জ করে দেবে।
হ্যাঁ হ্যাঁ।
Okay, so it is clear.
ইয়েস
ইয়েস
ম্যাম।
ম্যাম।
Okay. Now another problem is there. Write down the simplified Boolean expression in sum of product form and product of sum form for expression here. So only this expression is given in the sum of product form, but here it is given write down the simplified Boolean expression in product of sum form also. Then how we can get the expression for product of sum? When the expression is given in sum of product form, these are the combinations for input combinations for which the output will be
ম্যাম জিরো হয়ে যাবে তো।
output
ম্যাম
will be
না,
one.
যা পজিশনস দ্যাট আর নট গিভেন।
Yes, that not a given. So here
ইয়েস
you
ম্যাম।
can write another expression. Y is a function of A, B, C, D in this form, that is product of max term, and find out which terms are missing here. So 0, 2, 3, 5, 7, 8, 12, and 30. So I hope you can solve these problems with the help of Kenneth. Is it?
ইয়েস ম্যাম।
Okay. I will share this document with you, and you can you will show the various possibilities for making pair, quad. Here the representation is given for grouping of 2 adjacent cells, or grouping of 4 adjacent cells, or grouping of 8 adjacent cells. Okay. These 4 corners also make a quad. These 4 corners also make a quad. Okay. Now another concept is there, which is known as don't care combinations. What is this don't care combinations? Do you have any idea?
ম্যাম ডোন্ট কেয়ার কম্বিনেশন মানে ম্যাম, ম্যাম যেটা ম্যাম জিরো আর ওয়ান এর দুটো করে ম্যাম ভ্যালু ম্যাম দেবে, মানে মানে দুটোর ক্ষেত্রেই পসিবল, মানে ম্যাম পেয়ার বানানোর জন্য ম্যাম ওটাকে কনসিডার করা, মানে ওটা হবে আর কি।
Okay. So what is don't care conditions? Sometimes the design specification is given for designing the logic circuit, and this design is very much specific. Specific means Designer will get the idea from the specification that for which combinations of the input the output will be 1, and for others combinations designer take the value 0 for designing purpose, because the ones are given for a particular combinations. Here it is known as the function is given in specific form. But another form is given which is known as incompletely specified functions. Incompletely specified functions means sometimes customers provide their specification which is not defined or not cleared. Suppose the designer should design the circuit taking 4 input variables, because he got the idea that with the circuit should have 4 input variables. But these 4 input variables, there are 16 combinations. But only the customer provides that for these 5 combinations, we need the output 1, and for these 3 combinations, we need the output 0, but that's all. So, among 16 combinations, only 5 for which combinations the output will be 1, and for 3 for which the output is 0, it is given. But for rest of the combinations, the customers does not provide any combinations. It will be 0 or 1. So in this case, the function is not defined, that is incompletely defined. And when the function is defined in this way, then designer can take the advantage of that. How? If we consider the functions will be solved by the sum of product form or product of sum form, then we can take some combinations for which the output may be 1 if we go for the sum of product technique, and if we go for the product of sum technique for solution of the circuit, then the designer can take few combinations for which the output will be 0. What is the advantage for that? If we take few more ones in the K-map in case of sum of product form, or few more zeros in some cells for product of sum form, then using those ones or 0 in case of sum of product or product of sum form, by taking these ones, we can reduce the output expression in a far better way. So, designer takes the advantage of that. And in those cases for which the output combinations is not defined clearly by the customer, then we will take 1 if we go for the sum of product technique, or we can take 0 for that cell in case of product of some form. So the output may be 0 or maybe 1. Okay. So when the output may be 0 or maybe 1, we should write it in the corresponding cell by the symbol cross or D or phi. Is it clear?
Yes, ma'am.
So now, when an incompletely specified function is simplified to obtain minimal sum of product expression, the value 1 can be assigned to selected don't care combinations. And when a function is simplified to obtain minimal product of sum expression, the value 0 can be assigned to selected don't care combinations. So in order to increase the number of ones or zeros in the selected groups, which results in further simplifications. That is the advantage for designing from the designing aspect. So now the first problem is given in sum of product form, which is given in the minterm, and some combinations we are taking as a don't care. So how we can write this? Summation of don't cares D. For these three combinations, we will take one in the corresponding cells. But when we represent it in the K map, we will write cross, or you can write small d, or you can write phi. So here I am taking cross for the corresponding cells 0 to 5, here cross, cross, and here cross. It means these cells, for these three cells, the output may be 0 or maybe 1. But when we are going to simplify it using the sum of product form, obviously we will consider this don't care as a 1. So now problem is given and try to solve this and verify your answer with this.
ম্যাম এখানে ডোন্ট কেয়ার না দিলে তো চলবে?
Which one? 5.
আর উপরের লাইনটা এই যে এ বার বি বার।
There are two kind of solutions. One is taking these two don't cares, you can make a quad. Otherwise, by considering this cell, you can take this quad also, ignoring these two. Okay. So the result, either it will be CD plus A bar B bar or CD plus A bar D. Is it clear to all of you? Please check. Or if you have any query, you can ask me. Those who are present here, do you have any query regarding this solution?
No, ma'am.
No, ma'am.
Okay. So some problems are given in this form. When some values for minterm, it is confirmed for that combinations the output will be 1. But when it is given in this form, don't care, so output may be 0 or maybe 1. Now here also, but you can solve it, but the presentation will be in this form. Product of max term, then dot, don't cares are given in this form. Okay. So here it is given in plus, then summation d, and here it is given in dot d, and you can check the result. Now here you can see 1, 2, 3, 4. If we consider this 4 don't cares, then we will take these 8 adjacent cells and it make an octet. Okay. And from octet, how we can reduce? Take this. From here, you can drop the literal D first from these two. D, D bar. So you can drop it. Then you have only C bar here. And from these two adjacent cells, you will get C only, because you can drop D bar. D plus D bar give us 1. Then finally you have C bar here and here C. So again C bar plus C give you 1. So when we are taking this octet for these 4 combinations, what will be the result? It will be 1. And from this side, B bar is there. So B literal we can drop, and finally it will be A. So in the maximum representation, it will be A bar. Is it clear or not?
Yes, ma'am.
Please check. If you have any doubt, you can ask me. How we can reduce when octet is there. And another two, I hope you can identify this 4 adjacent cells make a quad, and here also 4 adjacent cells. It forms a quad. Quad 1, quad 2, and here it is octet. Shunayana is there? Shunayana?
Ma'am, she wrote in the chat box.
When I am presenting, na, don't write anything in the chat box. Just give me an answer. Shreya is there?
No, ma'am.
Why?
Ma'am, I think she has some net issues.
Okay.
Yeah, yes, ma'am.
So I think this problem is over.
Yes, ma'am.
Okay. Another problem is there, which is given in the sum of product form. Now just I give you some idea about the circuit design, how we can design the logic circuits, which is known as combinational logic circuit. All the digital circuits are classified into 2 categories. One is combinational logic circuit, another is sequential logic circuit. So what is the difference between these two? Do you know these two terms, combinational or sequential? So now combinational means the logic circuits that we can design with the help of basic logic gates only, like AND, OR, NOT, NAND, NOR, XOR, XNOR, this. And in this kind of circuit, the output is depend only on the present state inputs. Output, what will be the output? That will be the function of the inputs only. So at any moment, what will be the output? It will depends on the input combinations present at that moment. Another circuit is there which is known as sequential logic circuit. And this sequential logic circuits, we can build it with the help of flip-flops. which is flip-flop. Flip-flop is basically the memory unit. We'll discuss about the flip-flop in the class when we will talk about the sequential logic circuit. So now the concept of sequential circuit is the output of the sequential circuit depends not only on the present state input but present input. It also depends on the last output or the previous output. So where this previous output will be available? This previous output will be available in the memory cell. That's why with the help of combinational logic circuit and, and the memory unit, which is basically flip-flop, you can design the sequential logic circuit. So now we are going to design the first one, that is different kind of combinational logic circuit. These two terms are clear to you?
Yes, ma'am.
Yes, ma'am.
So now we are going to the designing of a combinational circuit. What are the steps for designing any kind of combinational circuits? From the word description. Word description means problem statement will be given in the word description form. Either it is given in the statement form or it may be given in the truth table form or it may be given in the form of Boolean expression. But if it is given in the word description form, then from the word description of the problem, identify the inputs and outputs and then draw a block diagram. Block diagram means first think about the circuit, go through the word description, that is problem statement, read it, and from there identify how many inputs will be there and how many outputs will be there. Then only connecting, suppose there are 3 inputs and 2 outputs. So draw a box, add 3 inputs and 2 outputs. This is the block diagram. Then draw a truth table such that it completely describes the operation of the circuit for different combinations of inputs. What is given? The customers gives the idea, that is for these combinations the output of the circuit will be 1 and for the other combinations the output will be 0. So from this idea draw truth table. So next step is truth table, and from truth table you can write the Boolean expression in the form of sum of product, that is Boolean expression for the output in sum of product form, because for simplification we need to solve the problem with the help of K-map technique. So when Boolean expressions you can find out it, from this expression you can draw the K-map, and from the K-map you will get the simplified expression, and this simplified expression can be implemented by the logic gates. Is it clear to you?
Yes, ma'am.
So what are the steps? I hope it is clear to you for designing any kind of circuits.
Yes, ma'am.
Now just I am taking, time is over, it is 3:31. So I am giving you one idea and this is your homework. Try to design it. I am giving you the problem statement. Design a single bit magnitude comparator. Design a single bit magnitude comparator. Please write it. Single bit magnitude comparator. Have you got the idea about the circuit, the functions of the circuit? Single bit magnitude comparator. How many inputs will be there? How many outputs will be there?
No, ma'am.
So now from single bit magnitude comparator, it means two numbers are there and each number has a one bit only. So there are two numbers of two one bit number. Got it?
Yes, ma'am.
Two one bit numbers. Suppose it is one is A, another is B. It may be 00 or 01 or 10 or 11. Clear?
Yes, ma'am.
Then for magnitude comparator, the circuit will test the magnitude of both the numbers, right? So numbers may be equal, may be unequal. So one output is for equality testing, but for unequal, what are the two different combinations? A may be greater than B or A may be less than B. Is it clear?
Yes, ma'am.
So now you have got the idea that the circuit, it will have two input variable and three output variable for checking whether A equals to B or A is less than B or A is greater than B. So now this is the block diagram. Actually this is black box. You should design the circuit. A and B, these are the two inputs and three outputs y1, y2, y3. When y1 will be high, if the number A is greater than B, then this output will be high. When this output will be high, if A equals to B, then only this output will be high. When this output will be high, if A is less than B. Clear?
Yes, ma'am.
Then what will be the next step? Truth table. These two numbers A0 and B0. It is for single bit. If it is 2-bit comparator, then one number it will be A0, A0, A1, and another number it will be B0, B0. B0, B1. That's why it is written in this form A0, B0. So write A0, B0. Check. This is the output for greater than checking. This is for equality. This is for less than. Okay. So here three outputs and inputs. This is the truth table. Write all the combinations. Up to this I will discuss. Okay. Now write all the combinations 0, 0, 0, 1, 1, 0, 1, 1. What will be the output here? Who can say this? This Y1 indicates 1 when A greater than B. In which combinations the output will be 1? For this combination only?
Yes, ma'am.
Why? Because A is 1, B is 0, right? So A is greater than B. Is it?
Yes, ma'am.
And for the other combinations, it will be 0. Because check 0, 0, it is equal, not less than, greater than. 0, less than 1. 1 equal to 1. So for equality checking, what will be the output? When the output will be 1? When both are same?
Yes,
Here
ma'am.
both are same, both are same. So these two combinations will be 1 and for others 2, 0. Here it will check A is less than B. So A is less than B here, right?
Yes, ma'am.
So now truth table you have, and from this truth table you can write the output expression in this form. From here you can write y1 is the summation of min term 2 only. From here you can write it for 0 and 3, summation of min term 0 and 3. From here you can write it is summation of min term 1 only. Then as there are two inputs, the 3 K-maps you should solve for to get the value of y1, y2 and y3 in the minimization form. So draw this Carnot map. You will get y1 from here. It will be these combinations A naught, A, B naught. From here it will be A, B, A naught, B naught, and from here it will be A, B. So here it is given, and this is basically the X NOT gate. And from here only one existing here, so it will be A naught, B. So A naught, B, and this is the circuit diagram completely, and this is the circuit which is in the black box. That is 2 inputs, 3 outputs, and in this way you can draw this. So this is actually for your homework. So up to this, if problem statement is given, I think you can approach for the last line also. Is it?
Yes, ma'am.
So please try it at your home. It will take 5 to 6 minutes, 5 minutes maximum. Now please give me the attendance. Roll number 61,
Present, ma'am.
62,
Present, ma'am.
63, 63, 64,
Ma'am, 63 present, ma'am.
63 acho. Tablet 64, 64,
Ma'am, 64 absent.